So my name is Samuel and I'm the instructor for quesadillas. For our project, we decided to make a machine learning model that would predict how likely someone is to have a brain stroke or not. And so without further ado, I'll let Daniela show off the video that students created.
Now I'm going to hand it off to Ruben for our inspiration of our project.
Hi guys, my name is Ruben and I'm the web designer of the team, and today I'll be talking about brain strokes, mainly the background of brain strokes, what they are, how they impact the US as a whole. So let's get right into it. First of all, brain strokes are when blood is blocked from reaching parts of the brain or when a blood vessel in the brain is ruptured. And this could happen to anybody, although 1 in 20 of all adult deaths in the US are caused by brain strokes, but really it can happen to all ages, genders, and races, name it. So this makes it really a dangerous, I guess, death in the US that we should all try to, avoid or at least decrease our chance of it occurring. And down below, there was a quote that our team picked out from the CDC, or otherwise known as the Centers for Disease Control and Prevention, and that 800 people have a stroke each year, but more than 140,000 die and any survivors face disability. That's really shocking, and especially towards the bottom of the last line, nearly 80% of these strokes are preventable. So my team took that in creating this model, and we decided we were planning to make this model in order to decrease the number, 800,000, and of course the 140,000 in the future or even now with our model. Before we can even make the model, we first need to get a bunch of data. And with that, I'm going to pass it on to Disha, who'll be talking about it.
I'm Disha, the machine learning engineer for Quirky Quesadillas, and I will be briefly going over our website's data page. So this data page presents the use of visual maps to identify similarities and determine stroke likelihood. The page showcases trends found in the database related to condition, age, and other factors impacting stroke risk. As you scroll down the page, you're able to view more insights and trends. Now let's take a look at the EDA. So the two main graphs on the right depict connections between average glucose level, BMI, and age with stroke patients and non-stroke patients. According to the graph of stroke victims, which is the one on the top, people who have higher average glucose levels are more likely to have a stroke than those who have lower levels. For both of the figures, people with median average glucose levels are less likely to experience strokes. The data also shows that older people, especially those over 60, have a higher risk of stroke because their arteries are narrow and stiffer, which tends to increase with age. Overall, these findings highlight the need of maintaining normal glucose levels and taking aging into account when developing stroke prevention measures. Now I'll be passing it on to Deetya to go over the findings for the correlation map.
Hi, my name is Deetya. I'm the data scientist for Quirky Quesadillas. So we made the correlation map. To find the correlation between all our different factors. Unfortunately, our data set was not that great, so all of them had pretty low numbers. But upon further research, we found that glucose levels, and looking at the graph, glucose levels and age have the highest probability when compared to stroke. And we use that when we're creating our model to figure out which variables we need to impact and emphasis on. Passing it on to Daniela for the actual model.
Hi, my name is Daniella Lat, and I'm the project manager of Quirky Quesadillas. When creating the model and finding the average or the accuracy, we tested linear regression, logistic regression, k-neighbor classification, and decision tree classification. For our final model, we decided to use the logistic regression model, which achieved a 91% accuracy. Our main goal for the model was to warn the user if they are at risk for having a stroke. The model will receive a user's health information like their age, BMI, average glucose level, etc., and report whether they are at risk for potentially having a stroke or not. So here's our model. And for example, if we were to put in someone who's young, they have an average BMI and low glucose levels, or average glucose levels. Let's just say they're male, living in an urban area, they haven't smoked, but they have hypertension and heart disease. You can see that they have a low likelihood of having a stroke. But if we had someone who's older, with also an average BMI, but high glucose levels, no hypertension or heart disease, they have a high likelihood of having a stroke. If any of you guys want to test out any data, you can put it in the chat. Thank you for your time, and we're open for any questions.
I just wanted to say before you have any questions, how proud I am of my team. They did a really good job, both with the data set and the machine learning model, and as well as creating a really nice website to kind of present all of it. I know we had like a lot of struggles, especially in the second week when we were trying to figure out which model to use, because we had a lot of difficulties at first with having like a really high bias towards not having a stroke. And so that took us a while to kind of like figure out how to get our model to actually have accurate results. But in the end, they were really successful getting a 91% accuracy rate. And it kind of just shows how persistent they were and how dedicated to like the quality of their work that they are. So I'm just really proud of all of them for what they were able to accomplish in just 3 weeks.